we're finally going to talk about what this whole chapter is leading up to, which is right triangle trigonometry. I'm going to start by talking about something that we've already talked about, one of our special right triangles. And what we found out is when I've got a right triangle and I've got a 30-degree angle in there, I get a constant ratio between the different sides of my triangle. Okay, so if this is x, this was 2x, and this was x squared of 3. Now, regardless of what x is, the ratio of the opposite side, okay, so if I'm looking at my 30-degree angle, this would be the opposite side. This would be the adjacent side. And this we're still just going to call the hypotenuse. Okay? Now, regardless of what x is, if I want to know the ratio between the opposite side and the hypotenuse, it would be x over 2x, which reduces to 1/2. So any right triangle that has a 30-degree angle, if I take the length of the side that's across from the 30-degree angle and the hypotenuse and put them in a fraction, it's always going to reduce to 1/2. If I want to know the ratio of the opposite side to the adjacent side, that's going to be x over x squared of 3, which will reduce to 1 over the square root of 3. And if I rationalize this, I get square root of 3 over 3. If I want to know the ratio of the adjacent side to the hypotenuse, that's always going to be x square root of 3 over 2x. The x's will cancel, and it's the square root of 3 over 2. Okay? So these are the constant ratios that I'm going to get between the different sides. Okay, so if I'm going to compare the opposite side and the hypotenuse, I'm always going to get a ratio of 1 to 2. If I'm going to compare the adjacent to the hypotenuse, I'm always going to get a ratio of square root of 3 to 2. Now, this isn't only the case for 30-degree angles. I could do the same thing for 60-degree angles, right? In fact, I could do it for any angle that I want to. Okay, so if I were to look down here at like a 15-degree angle, okay? If I wanted to compare the opposite side to the hypotenuse, a over c, and in this similar triangle, I want to compare the opposite side to the hypotenuse, these ratios are going to be the same. Always the same. So this is some number, okay? This is some value. I don't know what that value is, but let's call that value alpha, okay? So if the ratio between the opposite and the hypotenuse side is always this value alpha, then that's a fact that I can use to help me solve things, okay? So what we've done is we've come up with terms to describe these different ratios, to describe the ratio between the opposite and hypotenuse. There's a term to describe the adjacent and hypotenuse ratio, and there's a term to describe the opposite and adjacent ratio. Okay? So these terms are the sine, the cosine, and the tangent. All right? And the way to remember which function does what is by the phrase SOHCAHTOA. Okay? So if you notice, I've got sine, so S. Okay, S. I've got C for cosine, and I've got T for tangent. Okay? Now, the OH that comes after the sine tells me that the sine equals the opposite side over the hypotenuse. Opposite over hypotenuse. The cosine equals the adjacent over the hypotenuse. And the tangent equals the opposite over the adjacent. Okay, so if we look up here at this generic triangle, if I want to know what What is the sine of angle A? I would write that like this. Okay, we kind of abbreviate this a little bit. SIN. So you probably saw this button on your calculator. This is what it's used for. The sine of angle A, so angle A is right here. And if I want to know what the sine of it is, I'm going to take the opposite side, J, and put it in a fraction with the hypotenuse, H. Okay? Let's say I want the cosine of angle C. Cosine of C equals the adjacent side, which would be J, over the hypotenuse, which is H. Now, adjacent has to be a leg. When I talk about the adjacent side, it's got to be the leg. Because really, if this is angle C, the hypotenuse is adjacent to it. The hypotenuse is the hypotenuse, so it can't be the adjacent side. So that leaves J to be adjacent. Adjacent means it's touching, okay? Now, if I knew what measure angle A was, the sine of A is just some number. It's a constant ratio, remember, okay? It's always going to be the same depending on what our degree measurement is. So let's take a look here. If I want to know what the ratio between the opposite and hypotenuse side of a 15-degree angle is, I would just do 15 degrees, what's the sine? This number is the ratio between the opposite and hypotenuse side of a 15-degree angle, always. So it doesn't matter what size the triangle is. If I make a fraction of this over that, I get 0.2588. Okay, so let's look at some problems. So find the sine, the cosine, and tangent of the acute angles of a given right triangle. All right, well, here's angle T. It's an acute angle. We never do trig with the right angle, okay? The right angle doesn't have a sine, a cosine, or a tangent. Only the acute angles do. So the sine of angle T, sine is from the so it's opposite. So across from this is 6 over hypotenuse. Now I don't know what the hypotenuse is, so I'm going to use my Pythagorean theorem to find out what it is. 6 squared plus 10 squared equals c squared. 36 plus 100 equals c squared. 136 equals c squared. So I'm going to square root both sides. This is divisible by 4. 4 goes in here 34 times. 4 is 2 and 2. 34 is 2 and 17. So this is 2 square root 34. Okay, and now I need to simplify so the 6 and the 2 can reduce. And then I need to rationalize. So I get 3 squared of 34 over 34. That's the sine of angle T. If I want the cosine of angle T, that's going to be adjacent to T, which is 10, over the hypotenuse, which is 2 square root 34. Reduce these, so I get 5 over the square root of 34. Rationalize, so I get 5 square root 34 over 34. Okay, the tangent is opposite. Tangent, TOA, opposite from T is 6. Adjacent to T is 10. Reduce these, so I get 3/5. The sine of G, G is the top angle here, so that's opposite of G, which is 10. Hypotenuse, which is 2 square root of 34. This reduces to 5 over the square root of 34, which rationalizes to be 5 square root of 34 over 34. Which was the same thing as the cosine of the other angle. Because if you look at it, the cosine of this angle is going to use this side and this side. The sine of this angle is going to use this side and this side. So we end up getting some repeated values. Well, that means the cosine of this angle is going to be the same as the sine of the other angle, right? Cosine would be adjacent, which is 6 over hypotenuse, which is what we had here. So that's 3 square root 34 over 34. I've already done the math for that one here. Tangent's going to be opposite over adjacent, so 10 over 6, which is 5/3. Okay? If we want to find the values of x and y, well, I've got this angle here, 70 degrees. And if I want to find x first, x is the hypotenuse, okay? And I know what the opposite side to the 70-degree angle is. So I know O, opposite, is 8. I know H, hypotenuse, is x. So I'm going to use a trig function that deals with O and H. Well, from SOHCAHTOA, OH is the sine. So I'm going to take the sine, okay, of 70 degrees. Okay, and I know that that should equal the opposite over the hypotenuse side. So on my calculator, I'm going to have the calculator tell me what the sine of 70 is. What is the ratio between the opposite and hypotenuse sides of a 70-degree angle? So 70 degrees, make sure you're in degrees and not radians. Okay, if you guys are getting wrong answers when you're doing this, let me know tomorrow and I'll fix your calculator. Some will say DEG at the top or RAD. And if you've got a button that says DRG with an arrow on it, that's the button you want to use to switch from degrees to radians. You want your calculator to say DEG. If you're using a TI-83, you want to hit mode and make sure it's in degrees and not radians. So I need to know the sine of 70 degrees. Well, here it is. Okay. So that means that sine of 70 I can replace with 0.9397. That equals 8 over x. So now I need to cross multiply to solve these. So 8 equals 0.9397x. Divide by 0.9397. Okay, and I will get 8 divided by the sine of 70 equals 8.51. So that's what x is. Okay, now to solve y, y is adjacent, and I know the opposite, so OA, tangent, so the tangent of 70 degrees should equal opposite over adjacent. What is the tangent of 70? My calculator will tell me that. Tangent, it's 2.7474. So we'll just do 7475. So 2.7475 equals 8 over y. Cross multiply. So I get 2.7475y equals 8. Divide by 2.7475. And I'll get y equals 8 divided by tangent of 70 equals 2.9191. 2.91. Usually 2 decimals should be good for the final answer, but when you're typing them, it's best to have the actual number. That's why I'm typing 8 divided by the tangent of 70 equals. So I don't want to type in 2.7475 because that's rounding. So you get 2.91, that's what y is. Now here's something you can do to help check your answer. I should be able to do the Pythagorean theorem and get something that comes out about right. So if I take 8 squared plus 2.91 squared and then square root that answer, Where's my square root button? There, okay. So we'll do 8 times 8 plus 2.91 times 2.91. Let's see. Calculator's not doing what I want. 8 squared is 64. 2.91 times 2.91. Add that to 64, and then square root it. 8.51, which is what my hypotenuse should be. Okay? So that's a way to check your answer. A real quick way to check is my hypotenuse the longest side? Yeah, it is. Okay? If your hypotenuse comes out to be something that's shorter than one of these sides, then you're definitely not in the right ballpark. Okay? So this is kind of the beginning of trigonometry and what it's used for, and then we're going to expand it into finding everything out about right triangles in some future lessons.